So the next set of reactions we're going to do is we're going to take magnesium sulfate, which is a colorless solution, and to that we will add iron, and then we'll also add copper. So what, again, we're trying to see the metals by itself, are they more active than the magnesium that's in this compound? So let's take a look. You probably should know the answer to that just based on what the first experiment did, but we're going to take a look. So I'm going to take some of the magnesium and add that to the Fe. Swirl that some. I don't see any bubble formation. The color of the iron looks to me as the same as it did before. I don't notice any change in the temperature of that solution. I'm just going to hold it up a little bit, but I don't notice any change. So did a reaction occur? We would say no. So what does that tell us? Fe is not more active than magnesium, which is what we came up with the first set of reagents. All right, I'm going to do the same thing with the copper or magnesium. To contaminate, cross-contaminate. So I'm just going to get a separate tube. So I'm going to add the solution to the copper metal. And if you notice, I don't see any change of the copper. It still has that rose gold color to it. I don't see any bubbles rising to the surface. I don't notice a temperature change. So for both of these, we would have no reaction, no change occurred. All right, in the next example, we're going to use iron 2 sulfate, which is that kind of amber colored solution, I would say. And let me just say this, anytime you're using the term solution, unless it's stated otherwise, it's an aqueous solution for that. So amber colored solution, I'm going to add that to our magnesium. And if you notice, we're seeing bubbles rising to the surface. And then I'm going to take a look at the magnesium also to see if it changed color. Maybe just very slight exothermic, but not near as much as what we saw in the first set of reactions with the magnesium. If we kind of, you can kind of tell that the magnesium has also turned dark, kind of a dark brownish black color. So, and that's different than a dark silver color. So the magnesium has changed color. We've got the bubbles forming. So did a reaction occur? We would say yes. And then I'm going to do the same thing with the with the copper, with the iron 2 sulfate. And sometimes it's a little hard to see here because the copper almost blends into the color of the solution, so to speak. So if I kind of tilt it a little bit to see more of the copper, I don't see anything changing with the copper. I do not see any bubbles rising to the surface. I do not notice a temperature change. So for here, we would say no reaction. And then the last set of reactions we're going to do involves copper 2 sulfate, which is this kind of blue color, almost maybe a turquoise type color there. So I'm going to add that to our magnesium, which is the silver solid. And so as you can see, we've got the magnesium, the reaction here, the magnesium is turning a darker color. There's bubbles that are being formed. If you take a look at the solution certainly has changed color as well. I'm just going to pull some of this or get the test tube so you can see the difference. There is a difference in terms of the color of the solution and now what we have in the test tube. So we had bubbles. We've got, there is an exothermic reaction, a little bit warmer to the touch. We've got the solution changing color, looks more like almost like an olive green, if you will. We've got the magnesium turning dark, may have just a slight reddish tint, does have a slight reddish tint to the solid of that magnesium. So did a reaction occur? We would say yes. And then we've got our iron in a test tube, and we're going to add the copper 2 sulfate to that. I'm going to get a spatula just so we can kind of pull that up to the surface. You may not even need that, but I'm going to see if I can, oh yeah, if you can see the red solid. So what's happened, and you can tell that that's no longer that light charcoal color. So what happens when we have these single replacement reactions, that's a great example of it with the copper. Notice the color of the solution above changed from that blue color to the kind of a greenish color there. I didn't see any bubbles. I don't notice the temperature change, but certainly we had a change in color from the solution we started with to what we end up with now. And I think we need to be a little bit careful when we say, well, the copper precipitated. What happens in the single replacement reactions, if a reaction happens where metal replaces a metal, the metal that's doing the replacing dissolves in the solution at the same time that the metal it's replacing comes out of solution. I hesitate to use the word precipitation because usually when we talk about a precipitate, usually when we have a precipitate form, you start with 2 solutions. We're not starting with 2 solutions here. I would probably just use the phrase that the copper came out of solution at the same time that the iron was going into solution, or at the same time that the magnesium was going into solution. So from these reactions, what you're now able to do is complete the reactions, write chemical equations for those, balance those, and then you can come up with the own activity series on your own. If you're not given the activity series, there's 2 ways to get it. You go to the lab and you do it, which is what we just did, or you look up some reference book and you find what the activity series is. And then at the end, we always put these in appropriate waste containers and then clean up at the end.